In this lesson, we're going to take a look at stoichiometry, which is really just counting atoms, keeping track of how much material we have, making sure that we are following our balanced chemical equation. So consider making carbon monoxide. We have carbon atoms and we have oxygen atoms, and those have different masses. A carbon atom has a mass of 12 grams per mole, or 12 AMU, and an oxygen atom is 16, which means if we were going to make carbon monoxide, we wanted one atom of each. We can't grab one atom, so we'd have to mass out equal amounts. But if we massed out equal amounts in terms of grams, we would have different amounts of atoms. So we've got to be able to convert between atoms and grams, which is what we've been doing all year long when we've been messing with moles and formula units and balanced equations. So we use Avogadro's number to convert back and forth between moles and atoms so that we can deal with small amounts, right? If I have a couple grams of something, I have millions to trillions to times 10 to the 23rd powers of atoms of things. So instead of talking about that many atoms, we talk about moles of atoms. Remember, 1 mole is 6.022 times 10 to the 23rd. That is Avogadro's number. And so we use a balance and we mass out moles or partial moles of atoms so that we can actually carry out our chemical equations. So stoichiometry, like I said, is using a balanced chemical reaction to determine how much reactants and products we will have. It's basically, we're using a recipe. A balanced chemical equation is a recipe, and we're going to use them to figure out how much stuff we need. So here we have C2H6 dicarbon hexahydride as a gas, reacts with oxygen gas, produce carbon dioxide and water. And we're going to use stoichiometry to answer this question. If we start with 3.75 moles of C2H6, how many moles of CO2 can I make? First step in any stoichiometric problem is balancing this chemical equation. And this one is going to be a little bit nasty because we've got oxygen as odds floating around here. So I see I have 6 hydrogens, but if I multiply this by 3, that's going to give me an odd number of oxygens. I want an even. So I'll go ahead and double that. I'll do 6 of these. That's 12 hydrogens, which means I'm going to need 2 of these to get my 12 hydrogens. It's 4 carbons, which means I'm going to need 4 of these to get my 4 carbons. And so that gets me 4 times 2 is 8 oxygens here, plus 6 is here is 18, and I can multiply 2 by 9 to get to 18. Did I do that right? 8 and 6 is 14. So not by 9, by 7. All right, so now I have a balanced chemical equation, but what that actually allows me to do is find my mole ratios, right? So if I look at this question, it says I start with 3.75 moles of C2H6. How many moles of CO2 can I make? Well, I know that 2 moles of C2H6 will get me, if you like, 4 moles of CO2. So all I have to do to answer this question is I can say, well, 2 is to 3.75 as 4 is to what, right? Because the mole ratio is not going to change. So then all I have to do is get 2x, right? I'm going to cross multiply here equals 4 times 3.75. And then x is 2 times 3.75, which is 7.5 moles CO2. Now, if I want to make 0.45 moles H2O, how many moles of O2 are needed? Well, H2O comes in 6s and O2 comes in 7. So if I want to make 0.45 moles H2O, so 0.45 H2O is to 6 H2O, as O2, how much O2, don't know, is to 7 O2. So same kind of thing. So now I have 6x equals 7 times 0.45, and I can divide both sides by 6 and get x equals 7 times 0.45 divided by 6, which is 0.525 moles O2. Right? So we use our coefficients to get our mole ratios. We know 2 moles of C2H6 will react with 7 moles of O2. We know 2 moles of C2H6 will produce 4 moles of CO2. We know 2 moles of C2H6 will produce 6 moles of H2O. All right, so a balanced chemical equation gets us our mole ratio, and our mole ratio allows us to get how many moles. Now, this next problem says, okay, well, now we're going to move back and forth between moles and grams, but that's okay. We've been doing that all year. We need our periodic tables, but we can do this. This is the same chemical equation, so 2, 7, 4, 6, and we start with 0.95 moles of O2. How many grams of CO2 can I make? All right, so now we're looking at how O2 is compared to CO2. Well, we know that 7 moles of O2 will get us 4 moles of CO2. And so if I have only 0.95 of this, this is equal to how many moles of CO2? So now I'm going to take 0.95 times 4 is equal to 7 times x, right? And so 0.95 times 4 divided by 7 gets me x, which is 0.54 moles CO2. That's not the answer to the question, right? It wanted to know how many grams of CO2 can I make. But now that we know moles, 0.54 moles, we know the molar mass of carbon is 12. We know the molar mass of oxygen is 16 plus 32, right? 2 16s is 44 grams per mole. Remember, I'm trying to go to grams, so I need to go ahead and multiply 0.54 times 44 grams per mole. My moles cancel, and I will be left with grams, and this gets me about 23.9, 23.89 grams of CO2. Okay, so it's just one more complication by adding in the mass to mole conversion. If I want to make 20 grams of CO2, how many moles of O2 are needed? Okay, well, now we're going to do the same thing in reverse, right? I want to make 20 grams of CO2. Well, how many moles of CO2 is that? So 20 grams is how many moles? So we're going to go ahead and multiply this by 1 mole per 44 grams, right? That's the same mole mass ratio that we had before. And 20 divided by 44 is 0.45 moles. So what we want to know is how much O2 is needed to make 0.45 moles of CO2. Well, we have CO2 is 4 to the mole of 7 O2s, 4 CO2s, that's capital O, to 7 O2s is the same as 0.45 moles O2 to how many moles, or sorry, CO2, to how many moles of O2. And so multiply by 7, divide by 4, and we get about 0.795 moles. Right? So it's just a whole bunch of unit conversion and ratios, and your balanced chemical equation is where you get your ratios.